Hello friends, today I am going to do the derivation of the most economical section of the triangular section. Let us consider the depth of the flow be y and the side slope be 1 is to z, means for 1 meter vertical distance the horizontal distance be the z meter. We consider this as a for 1 meter the vertical height we consider z as a horizontal distance. This is we considered here as a side slope. For 1 meter we consider z meter as a horizontal distance. We consider this as a o, this as a and this point as a v and this point as a c. And after that we considered for 1 meter vertical height we considered z as a horizontal distance. So 1 meter vertical equals z meter horizontal. For y meter vertical will be equal to z into y meter horizontal. We see now we see in this figure for this slope, if 1 meter is a vertical height, then we consider z meter as a horizontal. For y meter as a vertical, we got here y into z as a horizontal distance. So this will be y into z from c to b, and also will be this from a to c, y into z. Now we know that the area of the triangle will be equal to half into AC AB into OC, where half into AC AB is given by YZ plus YZ, that is 2YZ, and OC will be equal to Y, which is given in the question. Here we got area equal to 2 to cancel y square z. Now we take the weighted perimeter. Weighted perimeter means the AO plus OB, where the water will flow on the side of the triangular notch. So the weighted perimeter will be equal to weighted perimeter, that is P will be equal to AO plus OB, where AO here we got YZ and here we got Y, here we got 90 degree, means this side we will got root under y square plus y square z. This will be equals to y we get outside and the 1 plus z. Y here will be y square z square, here we got z square. Now for AO and OB, AO and OB will be equal same because this is a symmetry. So we can take it as a 2 into y root under 1 plus z square. From the area we can take value of the y will be equal to a by z to the power 1 by 2. Square will go on that side, a by z to the power 1 by 2 we can take it as a. Now we substitute the value of y from here, 2 into y a by z to the power 1 by 2 root under 1 plus z square. Now we can take this 2 as a 4 to the power 1 by 2, and a by z to the power 1 by 2, and this we considered as a 1 by z square to the power 1 by 2. These three terms as a power 1 by 2, so we can take 4 into a by z into 1 plus z square 1 by 2. Here in this side we have the p, so if you will take the 1 by 2 on this side, there will be the p square equal to 4 times a by z plus az square. Az a by z plus z square is here, 1 z will be cancelled, a into z. So for the minimum weighted parameter, we differentiate this equation with respect to z and equate it to the 0. So consider this as equation 1. So differentiate equation 1 with respect to z and equate to 0. So differentiating p square with respect to z will be equal to 2p dou p by dou z. In this side 4 will be the constant, a minus a by z square plus a. If you equate this as a 0, this will be equal to 0. 4 times minus 1 by z square plus 1. Here will be a common taken. 4 and a, if you will divide 0 by 4a, it will also be equal to 0. So finally we will got 1 by z square plus 1 will be equal to 1, and after that z will be equal to z square will be equal to 1 and z equal to 1. Z will be equal to 1. Now initially we assumed that for the vertical 1 meter, for the slope of the vertical 1 meter, we considered z as a horizontal distance. So finally we got the z value as a 1. Means for vertical 1 meter we have to consider the 1 meter as also as a horizontal distance. So the ratio of the vertical to the horizontal must be equal to 1:1. If you will consider in this figure this as a theta, suppose this as a theta, whole as a theta, and it will be the theta by 2, and we got the side slope as a 1:1. Suppose if you will consider this 1:1, means if you will consider y this, and this also will be the y, then tan theta by 2 will be equal to this as a y, and this also will be equal to y. If you will consider look at here, y into z, this is y. Let us see the value of the theta 2. Tan theta by 2 will be equal to p by b, means perpendicular by base, where p will be equal to yz and this will be equal to y. Now we considered, let only this figure, this we got theta by 2, and this we have y into z, this as a y. Now for first most economical section we got the value of the z equal to 1. So now we are going to find the value of the theta from figure. Tan theta by 2 will be equal to yz by y. Z, the value of the z we got 1. The value of the z we got 1, means y into 1 by y. Tan theta by 2 will be equal to 1. Theta by 2 will be equal to tan inverse of 1. Tan inverse of 1, which is 45 degree. Theta equal to 2 into 45 degree, which is equal to 90 degree. So for most economical triangular section, the value of the theta must be equal to 90 degree. Means the value of this theta must be equal to 90 degree for the most economical section. That is, most economical section means the discharge should be maximum for the minimum weighted area, minimum weighted perimeter, we can say weighted perimeter. For minimum weighted perimeter we try to get the maximum discharge. So for what perimeter we will get the maximum discharge, we will take. Now we have to consider the hydraulic depth. What hydraulic depth it must be? The hydraulic depth means we consider hydraulic depth. Hydraulic depth means m, which is will be equal to a by p. A means cross section area and p means weighted perimeter. Weighted perimeter, and this is equal to area of cross sections, area of triangular sections. Triangular section where area we got initially as a y square z, and the downside we got the weighted perimeter as a 2y root under 1 by 1 plus z square. The value of the z we got, 1 y square 2y 1 plus 1 plus 1 square will be only 1, means y cancel, y by 2 root 2. So for hydraulic mean depth we it should be the y by 2 root under 2. Thank you for watching.